So we'll say good morning and hello to Agnes and Bernice and Humphrey. All right, do you want to say hello? Okay, somebody said hello. There we go. So, Lois, could you just close over the door there? Thanks. So let's have a look at this one here. Okay, we've got a dominant allele. Causes polycystic kidney disease. Now, I don't know what polycystic kidney disease is. I'm sure you don't know. But actually, hopefully by now, when you do genetics questions, you realise that's not what they're going to ask you about. They're going to ask you anything about the condition. So don't worry if you read information that you've never seen before. The key thing is, though, that we've got big H causing this disease. So therefore, and you've got these 4 individuals that have the disease. You only know one individual's, well, straight away, which individual can you tell me their genotype? Just from looking at that. Patch. Who said Patch? Beth, can you explain why that is?
Well, because the allele of polycystic kidney disease is dominant, you would need to not have it, we need to have 2 homozygous recessive.
Yep.
So if you have enough age.
Yep, so basically, because that patch is normal, you know that normal is obviously going to be recessive. If the dominant one causes this condition, that's going to be normal. So you know patch is small h. Patch must have got a small h from each parent, but yet each parent has this condition, so they must also have a big H. So that's what you need to explain then. Explain how the pups show that Ben and Rosie are both heterozygous. So what I would say, and what the mark scheme is expecting you to say, is that Patch is small h. Or if you said homozygous recessive, you get a mark. And that means that he or she must get a recessive allele from each parent. But each parent has PKD or is a sufferer, therefore must also have a dominant allele. Okay, so look, there are 3 marks. Make sure that when you're answering anything that you look carefully and go back and make sure have I got 3 points. So you've said Patch, small h, must get a small h from each parent, but also each parent has a condition, therefore each parent also has a big H. Dog breeder wants to find out the genotype. So if you want to find out the genotype, you see there Willow has a big H, but we don't know whether Willow is big H or big H small h. So what's the kind of cross, Molly? Back cross or test cross, so 1 mark for that. So what do you cross it with in a back or a test cross, Harry? Can you remember?
Heterozygous and homozygous?
No, we know that Willow, we've said, has conditions. So Willow, I'll just draw down here. Willow could be big H, or big H, little h. We don't know. So what do we cross Willow with to find it out? In a test cross or a back cross? Alex, can you?
2 homozygous recessive.
Yeah, basically get homozygous recessive. It's always homozygous recessive. Because the homozygous recessive dog is the only dog whose genotype you are 100% sure of. So homozygous recessive, small h, that's normal. So far you get 1 mark for saying back cross or a test cross. And 1 mark for saying that you cross it with a normal or a small h, or homozygous recessive. Okay, if you say Willow could be big H, or big H, small h, that's another mark. Now, they don't ask you to do the cross, and some of you, if you're not sure, do it. So we're saying Willow could be big H, or big H, small h. If Willow is big H, all the offspring are going to have PKD. If Willow is big H, small h, half are going to be normal and half are going to have PKD. So far, we have 3 marks from what we've said, what we're going to do. And then you need to say if all the offspring are normal, if all the offspring have the condition or have PKD, Willow must be big H. If you get any normal, or if you get half them being normal, Willow must be big H, little h, or heterozygous. Okay, anybody get 5 out of 5 there? Good. Now that's one of the most difficult genetics questions. Anybody want me to explain anything or to go through anything there? Okay, question 2, mutations. What condition have we got there, Lois? Down syndrome. So obviously we've got 3 21st chromosomes. So that's the evidence that there's an extra chromosome. Well, really there's 2 marks there. So the fact there's an extra chromosome and it's the chromosome 21. And what evidence suggests these chromosomes belong to a human? You've never been asked that before. How do you know they're a human? Well, what are you looking for? Well, you know that humans have got like 23 pairs of homologous chromosomes. So if you say there's 23 pairs of chromosomes, you can't say there's 46 because there's 47. So the fact that there's 23 pairs of chromosomes, strictly speaking, you've got 1 triplet. So if you said there's 22 pairs plus 3 or 23 pairs, it's that idea that you're expecting 23 pairs of chromosomes. What's the evidence that they belong to a male? Jake, what do you think? X and Y. Good. Sorry, hold on. Okay, so we said there, the evidence is there's an X and a Y chromosome. So genetic screening, then obviously you can see they extract some liquid from the, well, what is the liquid? What is liquid X? Katie?
Amniotic fluid.
Yeah. Amniotic fluid. And that's that. Okay, so what I'm going to do, I'm going to give you time to do some more questions on your own and then we'll go through them. So I'll give you 2, 4, 6, 8, 10. Right, I'm going to give you 20 minutes. Okay, 20 minutes to do the rest of those questions. All right, 20 minutes to do the rest of the questions. You can use your notes if you want, but you're going to do them on your own, all right? 20 minutes.